Hello there, YouTubers, and welcome to another episode of DrCassette's Workshop. Today on the workbench we have this Aiwa integrated stereo amplifier. It is the model XA-003. There it is. It's kind of a basic unit. As you could tell, nothing too terribly special. Technically this is, well, it's kind of a mixed bag. It does have discrete output transistors. However, the driver circuitry is integrated in these two chips. Overall, I have to say this is probably capable of 100 watts per channel. Rated input is 250 watts, so 100 watts seems to be about accurate. Decent sized transformer, nothing too special, but it'll do it. Got some nice speaker terminals, screw-on things, speaker protection relay. This is kind of a weird thing right there. Seems like Aiwa kind of ran out of Nichicon capacitors during production, so they just tacked in this Elna right there. Not sure what's up with that. That's just some dried up glue right there, or if there is something wrong. Got a flimsy little rectifier bridge, and it's kind of wobbly, so may have to check the solder joints on that. We got this is a puny little regulator setup. You can see we got some flimsy little transistors, Zener diodes, and some capacitors. Really nothing special at all. That provides the positive and negative voltage for the op amps. There is one right there. It's probably a quad op amp. Actually, it might just be a dual op amp. Got another dual op amp right there. That's obviously for the phono preamplifier. And then for the tone controls, we got another one on the circuit board right there. Heatsink, nothing too special. Inputs, nothing too special. And, well, it doesn't work. So we'll have to find out what's wrong with it. We plug it in, it doesn't do anything, which is kind of what it should do. Is the main fuse is blown. So first thing I'm going to do is I'm going to replace the main fuse, and we're going to see if the thing powers up. Should probably test the transformer before I do that, but we'll replace the fuse. We're not going to short it out, because that would be a very stupid thing to do. And we're going to see what it does. I got the new fuse in its place, so let's go ahead and see if we can pop that if we try to power up the amplifier. The primary of the transformer seems to be fine. The secondary, not so much. I'm just reading a few milliohms, so that's kind of weird. Anyway, here we go. Let's see. Okay, well, that is obviously... that popped. So, something's got to be wrong in here. Well, there we have the amplifier taken out of the case. And as I expected, the solder joints of the rectifier bridge were in fact broken. This one up there was so badly broken it actually kind of ripped the trace off of the circuit board. Resoldering all the connections seems to have fixed that, so I won't have to make any additional connections to anything. It also seems like this kind of already fixed the amplifier, because I checked the transformer being detached from the circuit and it does work. Gives out about 25 volts per rail. It's a dual rail setup, as you can clearly see. And resoldering a bunch of joints on this board also seems to have fixed that. As well, previously I was measuring almost a dead short across these terminals. Now we're up to about 11 mega ohms. So I don't know what went wrong on this, but it seems like it kind of managed to fix itself, more or less. I took out these capacitors and checked those, and they are fine. Surprisingly, the crappy Elna capacitor was even better than the Nichicon. on the tester. I'm going to try to remove this glue, because that's always a potential source of trouble. But, well, I guess I'm now going to put this back together and we're going to see if that really was it. And as it turns out, what I did so far didn't help it at all. It's not the fault of the solder joints. So I lifted the legs of the output transistors and I found the fault. This channel right here is perfectly fine. This channel over here is totally blown. The connection between emitter and collector is just a dead short. 0 ohms according to the transistor tester. So I'll have to find a replacement for these two. I'm definitely not going to invest any money into this piece of junk. Well, let me take a look into my parts bin and maybe I can find something at least remotely similar to what is in here at the moment. With the blown transistors taken out of the circuit, as you'd expect, we can turn the amplifier on and it will work. That was the relay clicking, so that indicates that everything aside from those transistors should be fine. As I already said, I'm not going to spend a single dime on new output transistors, because this amplifier is kind of worthless. Came from the dump, it didn't cost me anything, and you know, I'm not going to be putting any money into this. The good news is I found some output transistors that I took out of a Yamaha amplifier, kind of a cheap thing, so these should work. They do have the same sort of case, same pin configuration. They have roughly about the same amplification, and they all seem to measure fine. The only problem is these have metal backs, while these are nicely insulated in an all-plastic case, so I will have to try and find some insulation material. Now, one thing left to do is to measure the voltage that the driver ICs put into the base, because if there is something wrong with those voltages, obviously if we replace the transistors, they're just going to blow up again. So I'm going to check the collector to emitter and base to emitter voltages. Measuring this amplifier with the output transistors taken out, and also these are probably for the temperature compensation. Measuring this doesn't really make sense because no matter what you measure, you're going to get 37 volts, also on the good channel. Voltages are all pretty much the same, so I'm assuming that everything is fine. But, that doesn't solve any mysteries, that's for sure. Anyway, and well, found some insulation material. The problem is it's got this nasty old heatsink grease stuck all over it, and this is so dried up I can't even wipe it off anymore, so we'll have to well, I guess we'll just have to do kind of a sloppy job and just put a blob of heatsink grease onto all the components and just kind of screw it on there. And there we have the new old output transistors mounted to the heatsink using some insulating sheets. As I already said, it doesn't look pretty, but it will do the job. As you can see, I now have the amplifier pretty much reassembled. The circuit board is back in its place with the new output transistors right there. Everything has been soldered properly. I resoldered a lot of the joints on this board. The input jacks, that was all. You know, some of the joints were bad, were cracked on this. I probably should have also resoldered the joints of the two ICs and the resistors, but I kind of forgot about that. Anyway, now comes the moment of truth. Let's see if this thing actually works. Go ahead. I have the plug plugged in, so we apply power. Let's see. First of all, let's take a look at the fuse, see what that does. Here we go. what do you know? We are getting some reaction, however, it sounded like it clicked and then immediately disengaged again. Yeah, that's what it did. Oh, okay, now it didn't. Okay, well, seems like that managed to fix itself. So let me go ahead and do some measurements, and if I should find out that the offset voltage present on the speaker outputs is tolerable, I'm going to get out some speakers and we can give this thing a bit of a test run. And here we have the Aiwa amplifier all back together, and guess what? It works. It works. I had to spray all of the switches, all of the potentiometers with lots and lots of contact spray, because that was a major problem on this. I could barely get the speakers to work at first. Of course, these stupid Alps switches are all sealed, so you can't really get any contact spray into there. So what I did was I took the soldering iron and I just melted some holes into the tops of those switches, and well, that did the trick. I could easily get the contact spray into there, really flood the switch with it, work it for a while, and guess what? Those switches are now perfectly fine again. Now, if I turn the volume up, we will have to find out that something is not perfectly fine. Really annoying, because it means that I'll have to take this whole damn thing apart again. I got the frequency generator hooked up to this. That's not going to bring us into any copyright problems. If I mess around with these ICs, hear that? These ICs, this might actually be the reason why this thing failed initially. What happened is these ICs are running incredibly hot. These things are boiling, they are burning, it's insane. The solder joints on these are all bad, and what you can hear is, depending on how you move them around, sometimes you get some pretty bad distortion into your sound. Basically, if you turn on the amplifier as it is right now, at first the sound is going to be terribly distorted, and once these ICs have warmed up, the sound is normal. It's all fine. Another thing is, with these things, as they randomly make contact or don't make any more contact or whatever, they generate pretty massive spikes. And that was when I first turned on the amplifier, I got some pretty loud pops out of the speakers, and I already thought I may have blown them. So that may have caused the one channel to blow up. I'll definitely have to take this all apart again and resolder these ICs, because the way this is right now, the amplifier is not going to work properly. Soldering in this amplifier is an absolute disaster. You can probably tell all the shiny solder joints are the ones that I redid. Didn't really do a whole lot over there, because that's all passive stuff right there. Resoldered the switches, the IC. These ICs, of course, that's the fault that we had. Those have been resoldered. You know, everything, the whole entire power supply part, everything that could get at least remotely warm, I resoldered. And I even resoldered this, a board on the transformer, and I tell you, the solder joints, even the solder joints of the fuse were bad. They were cracked. So that's pretty crazy. But I'm not going to complain, because I tell you, there are manufacturers doing this wrong that, well, where you really wouldn't expect it. Just yesterday I had a friend over here with his high-end Vincent brand amplifier. One of the channels was dead, and guess what the fault was? Bad solder joints. on a unit that I think he said it was about 3,000 euro when it was new. So, yeah. And now it finally works. Well, I'd say that still was quite a fun project. I will have to give this thing a bit of a cleaning, but for right now I'm happy and I'm tired. So I'm gonna leave you with just a very, very quick sample of how this thing sounds, just to prove that it does in fact work. And last but not least, a little mini review. Is this thing any good? Well, let me tell you, it does make some music. I just had it hooked up to my 1968 Bang & Olufsen speakers. Not in a very audiophile way. I had the loudness turned on, I had the bass turned up, and I had the volume turned up quite a bit. But it was fun listening to this. It really was, and that's what counts. So I'd say, for what this is, and that is a rather cheap, low-end amplifier, this is pretty damn good. This is pretty damn good. I mean, who knows, maybe by putting in those different output transistors, we may or may not have actually improved it. Of course, those output transistors, as I already said, they came out of a Yamaha amplifier, and I think that actually would have been a bit higher-ended than this. Bit better. Problem with the Yamaha, in case you wonder, was just a hideously bad design. I mean, the circuit board was just full of burned spots. Really, literally burned spots from transistors running way too hot, from resistors running way too hot, and when I saw that I was just like, no, you're not even going to bother with that thing. That thing, when it comes to the thermal design, was just an absolute disaster. And I mean, well, you're not supposed to run resistors that hot, so the Yamaha engineers definitely messed up there. But anyway, the thermal design is also a bit of a problem with this. Of course, one of the aims of running this with the loudness on, with the bass turn up, with the volume turn up, was to really put a bit of a load on this, and I tell ya, that heatsink down there, this flimsy little thing, is burning. You don't want to touch that thing anymore. I tell ya that. Don't know what's up with these driver ICs, but I guess those are going to be fine. Of course, the amplification of these transistors is a little bit higher than with the original ones, so the driver ICs, for the same kind of output volume, the driver ICs will actually have less of a load on them, which is pretty good, probably. Well, anyway, so that's that. The Aiwa XA-003 amplifier. If this thing would have worked perfectly, I probably really wouldn't have bothered with this at all. But with this thing being broken, it actually turned into a nice little Saturday night challenge. Well, thank you for watching, and see you again soon.